Welcome. Step into the lab. On this podcast, we will be discussing the practices, research, science, and technology surrounding alternative medicine, where listeners will gain valuable insight and information with every episode. Just as a reminder, the Mind or a Lab podcast is for educational and informational purposes solely. All subjects on this podcast should not be construed as medical or legal advice. You should always seek out help from a professional provider. Thank you. Hello, everyone. Welcome to I think this is now the 13th episode of the Mind or a Lab podcast. And today I have Alexey, and is it Peshkovsky?
Peshkovsky. Yeah.
Alexey Peshkovsky
Perfect.
with Industrial Sonomechanics. And I met these guys over at MJ Biz Con back in 2023, and their technology stuck out to me, and I was like really looking to see who were big innovators in the cannabis industry space, and I wanted to sit down and have this conversation. So, Alexey, could you just share a little bit about your background and where your company is based out of?
Sure. Personal background: I was born in Moscow, Russia, back when it was Soviet Union. I left in 1990. I mean, hence the last name, obviously.
Yeah.
So I left 4 years ago or so. Um, in 1990, I studied chemistry at Moscow University for
Mm-hmm.
a couple of years, and then I got my bachelor's degree in chemistry at the University of Pennsylvania after I came
Okay.
over. Then I went for a PhD in physical chemistry at Columbia University in New York. My specialty was nuclear magnetic resonance,
Okay.
NMR, solid state
Mm-hmm.
NMR. And then I transferred over into MRI, magnetic resonance imaging, mainly for medical, more investigations into medical physics,
Mm-hmm.
human brain. I did functional MRI instrumentation development for a few years. Then I worked in explosives detection after 9/11
Oh
a little
wow.
bit because I figured if MRI can see inside your brain, I can use something similar to see inside your bags. but
Yeah. Yeah.
but the concept was to see inside people's bags without actually understanding what they have, so as to
Mm-hmm.
protect their privacy, but only focusing on whether there's a particular plastic explosive type
I see.
molecule in there. So that was one of the postdocs. I did it in Argentina actually, and uh, al- along some other projects. But my father, um, he was an ultrasound physicist his entire life,
Mm-hmm.
instrumentation
Mm-hmm.
development for ultrasonics, and he really wanted to do something together. And I'll tell you all more details on that a bit later. But somewhere around my third postdoc, well, I had my own career path. Uh,
Yeah.
MRI, I didn't really want to do other things. I liked what I was doing. I was making pretty cool instruments, as I thought. But in Argentina, you get kinder to your family. That's just South
Mm-hmm.
American way of being. You get like very good to your elders, and so I considered what he wanted me to do, and as soon as I looked at it carefully enough, it became apparent that it was just extremely interesting and very similar physics wise. Just
Mm-hmm.
all the mathematical treatment of all the resonators and things was so similar that it wasn't even a big leap. And so we started working together after that, and then Sonomechanics was born out of that. And so
Okay.
since about 2004, I switched
Mm-hmm.
into ultrasonics, and we formed industrial sonomechanics together with my father. He was
Mm-hmm.
still living in Moscow, never came over to live here, so he was remote. I was running it from here, and we started working together, and that's the origins of sonomechanics and my own history.
That's awesome. So you were heavily influenced by your father when you were younger to get into a scientific background.
Yes, for sure. We had conversations all the time about this stuff, and every dinner was basically a symposium. Every Saturday, Sunday dinner was always a conversation about something super cool. So yeah, and I really liked what he was doing. I always had an attraction to things like that, and I guess I
Mm-hmm.
followed. I deviated in the specifics for a while, but then even that didn't last for too long. So yeah, I pretty much
Yeah,
followed my father.
amazing. So yeah, you have a very astute track record of being in chemistry, then focusing on physics. So, what was the mission of starting industrial sonomechanics?
Well, um, ultrasound is kind of an interesting beast. It's used in the lab
Mm-hmm.
throughout the world mainly in universities and small labs
Mm-hmm.
for a huge variety of different processes,
Okay.
from the pharmaceutical, from cell disruption to creating nanoparticles to degassing and alternative fuel production. If you look up papers on sonication and its effects, they're all over the physics, engineering, and the chemistry world. Sonic chemistry is a whole branch of science, and that's just the chemistry side, right? Um, However, ultrasound has also always been a non-scalable technique
Okay.
because of some technological limitations. I can explain a little bit more about those. So, even though you can use it on the lab scale and you can
Yeah.
create very interesting processes, potentially very useful, it hasn't been possible to implement them at the industrial level.
Okay.
Now, the invention that my father came up with theoretically, and then we reduced it to practice, uh, it's the invention we call the barbell horn. The barbell horn ultrasonic technology is the type of technology that is the core of our company. So, the barbell horn is a device that allows you to scale up an ultrasonic process. In other
Okay.
words, what we're able to do is take anything that is successful on the lab scale and
Mm-hmm.
bring it to production, scale it up
Okay.
by orders of magnitude without changing the quality the quality of the finished product, basically without
Mm-hmm.
changing the local conditions that the material experiences. The only
Right.
thing that changes is you can process a lot more material in the same amount of time.
Okay.
And so our mission has become to implement, to assist companies to scale up very interesting and basically myriad of ultrasonic processes that have only been possible at the lab scale previously. This is our mission, I would say, um, across applications. Now, we also specialize in some applications more than others.
Okay.
We haven't started. When we first started, we kind of went for everything. Wherever people had an interest, we would create a system for scaling up that. But over time, we've started to focus on some things a lot more than others, specifically uh, the production of nanoparticle formulations,
Mm-hmm.
nanoparticle containing formulations, such as nanoemulsions, nanocrystals, liposomes, things like that.
Hmm.
for mainly for drug delivery, for delivering
Okay.
a bioactive substance into the bloodstream. Uh, the industries that are interested in something like this are mostly the pharmaceutical, nutraceutical, and by extension cannabis, because it has elements of both. Um, in order to deliver certain types of um, biologically active substances into the bloodstream, you have to make nanoparticles out of them.
Hmm.
Within that industry, we have sort of a mission um, in its own right. And the way I see it is, or rather, what I think we're doing is we're building an equivalent of a USB port um, for something to be delivered into us as a machine. So what I mean by that is this: computer hardware
Right.
uh, is sort of um, this being, artificial being, right? It
Hmm.
functions because it has all the elements of its hardware and it has software. That software has to be uploaded, brought in. So I would
Yes.
say our bodies, our brains, and the receptors in our bodies, in our cells, are sort of a computer, let's say, right? A device. And what you're bringing in are chemicals, uh, bioactive chemicals. They interact with us and and affect us in different ways. Kind of an equivalent of software.
You're right.
What we build is the ability to deliver that, which is kind of a USB port, right? You plug in an external hard drive and you can upload things. So we build USB ports and data transfer protocols, if you will, right? What we do is we develop systems for you to be able to upload biologically active molecules into your bloodstream and therefore into the rest of your body efficiently and safely.
I really like that analogy. That makes a lot of sense to even just the common person of like, all right, our bodies are the machines, and you're downloading packets of data or new software as you're putting it,
And uploading.
and yeah, and you're uploading it right via the USB, that the little stick drive. But in this case, you're comparing that to coding those biologically active components that are going to get uploaded to your body. So, if you could please explain the process of turning basically oils into powder forms, that would make sense. Like, that would make sense to basically someone who doesn't have a background in science
Hmm.
at all.
Yeah, we're not exactly, I wouldn't say we're coding them. We are packaging them so that they
Okay.
can smoothly and safely go where they need to go.
Mm-hmm.
And the reason that we have to do it is because on their own they don't. And that's kind of the whole point.
Mm-hmm.
Um, so oils are difficult to bring into your bloodstream in general.
Mm-hmm.
By oils, I don't just mean vegetable oils, although those two, they do go in because they're
Mm-hmm.
digestible, but they don't go in quickly. And some other oils might not even go at all. Um, Oils and things that dissolve in oil, lipophilic substances, they're called
Yes.
oil soluble materials. Actually, a better way probably to say it would be hydrophobic, which is not exactly the same thing. Things that don't dissolve in water, which doesn't
Mm-hmm.
necessarily mean that they dissolve in oil. They might just not dissolve in anything. So
Mm-hmm.
things that don't dissolve in water are typically difficult to deliver into our bloodstream. And
Right.
very roughly speaking, that's because, well, we are mostly water. Our gastric fluids are water. Our bloodstream is most certainly mostly water. And in a nutshell, you have to be able to mix with water in order to get through water and be in water, and then
Mm-hmm.
be brought by a stream of mostly water to all the right places. Uh, it turns out that our bodies, it's not that they don't allow oils through. It's just that they have a particular process by which they do that. And
Mm-hmm.
when I mean deliver, I mean digestively. You can trick your body and use a different route, a route that your bodies don't naturally expect. For example, you can vape, right? You don't
Mm-hmm.
expect oils to go through your lungs into your bloodstream.
Right.
And yeah, you can do that, and that's quick. And everyone who smokes or vapes knows that. But the problem is because your bodies don't expect bioactive substances to be brought in that way, the safety procedures are not there. So
Mm-hmm.
if your vape juice is incorrect, or if your joint has things you it shouldn't have, which most of them do, I would say maybe all of them
Yeah.
do, right? Then there's all kinds of health issues. I mean, you put
Mm-hmm.
vitamin E in your vape juice, and several people died, I think, just a couple of years ago just from that,
Right.
right? Digestively, we are much more resilient because animals eat all kinds of stuff, and they have livers to clean it up. They have, even before things are brought in, there's all kinds of scrutiny that happens because who knows what you ate. You have a way of getting rid of it if it doesn't belong, and so on. So the way your bodies bring in, let's say, vegetable oils,
Mm-hmm.
is you swallow something with a fat or oil, right? In the beginning, it doesn't go anywhere. It just kind of arrives in your, well, goes through your stomach into your small intestine, and then sits there, kind of like an oil blob. And then lipases and phospholipids come to it, and lipases uh, clip glycerin group from triglycerides. Basically, they liberate free fatty acids. They break up the
Mm-hmm.
oils into these free fatty acids, which are still not water soluble, but they can be packaged together with some emulsifier like entities that you naturally have released by the pancreas. They're packaged into something called mixed micelles. Mixed micelles are nanoparticles of mainly free fatty acids with some other things. There
Mm-hmm.
is something like 6 to 20, maybe 30 nanometers in size, small droplets. Now, those droplets can travel through water because they're very small, and even though they're composed of these oil characters, they're hydrophilic on the outside. That's the function of
Mm-hmm.
the emulsifier. So they're water
Yep.
compatible. Now they can travel. They can get to the inner wall of your small intestine. To get there, you have to go through a mucus layer. It's called unstirred aqueous layer. It's water and it's not stirred. So if you don't dissolve in water, you're not getting through it. But if you're a
Mm-hmm.
small droplet like this, then you can kind of diffuse through. Then you get to the inner wall of your small intestine, and there you can get absorbed into the enterocyte cell. Now, if you consume, let's say, a cannabis edible,
Mm-hmm.
and it's better if you consume some fat with it. Everyone knows it hits you harder if you do that, right?
Mm-hmm.
And that's because when these mixed micelles form, they will take THC or whatever CBD or whatever cannabinoid you consumed and bring it into its interior because that's where the oils like to be. That's a hydrophobic
Yeah.
environment. But the whole thing is still the small 20 nanometer particle, 20 to 30. Now it's a swollen micelle, it's called, because it has something on the inside. It can travel and bring it in. Now, the punchline to this is to form these micelles, it takes about an hour and a half or so.
Okay.
That's why edibles hit you 2 hours later. They take
Mm.
forever to get into these transportation devices.
Okay.
Okay, now what we create with nanoemulsions are
Mm-hmm.
basically suspensions of 20 to 30 nanometer or so, right? Droplets that, in most ways that matter, mimic mixed micelles. So they're ready to go. You consume a beverage with a nanoemulsion with THC in it or CBD or whatever,
Mm-hmm.
it you can feel it in 5 7 minutes because
Wow.
the whole process of forming these things in situ is not necessary. Now that's the the reason to make nanoparticles out of water insoluble bioactives. That's just so
Mm-hmm.
you can use a normal from kind of an animal perspective way of bringing bioactives into a body, which is oral digestive, but speed
Mm-hmm.
it up tremendously and improve its efficiency because you're skipping this whole slow and kind of inefficient process of creating these same particles but in situ. Now, powders um, are still so the powders that we make or enable our customers to make are very similar to these liquid nanoemulsions. Um, they are basically also suspensions of oil droplets in what is very similar to water, except it's
Mm-hmm.
not water. It's something that behaves very much like water and it is water soluble, but just happens to be solid at room temperature.
Okay.
An example of that, which I don't mean it literally. We don't use uh, this, but it would be a good example of something like that. It would be table sugar. So table
Okay.
sugar is polar, in many
Mm-hmm.
ways similar to water, dissolves in water,
Mm-hmm.
and you can suspend oil droplets in it.
Okay.
Basically, the whole thing is solid, and so you can grind it into a powder. As soon as this powder hits water, sugar dissolves out, the droplets are released, and now you're back to a liquid nanoemulsion you started with. So that's
Right.
how you turn oils into nanopowders. This
Mm-hmm.
powder could be consumed directly, for example, in the form of a tablet, even a quick disintegrating or chewable tablet, which will dissolve in your saliva and reconvert into a nanoemulsion, and then it's kind of like the same as a beverage. Or you can
Mm-hmm.
swallow it, it'll dissolve in your gastric fluids. Or you can put this powder into, let's say, a coffee, mix it with, put it into a K cup, let's say, and brew it out.
Mm-hmm.
Or put
Right.
it into instant coffee and stir it in. It's basically a liquid nanoemulsion in a solid powdered form until it hits water.
That's awesome. Yeah, that's awesome. So thank you for that breakdown. I'm gonna ask, do you think that a majority of cannabis companies are adopting this method of delivery, or do we have a long way to go in terms of bioavailability?
Well, I can't speak for the majority necessarily, but we have thousands of clients and we continue to generate a lot of interest and
Mm-hmm.
um, people keep coming for this and I feel like it's growing. I
Mm-hmm.
don't think it's growing as fast as we all thought it would. Something like
Mm-hmm.
3 4 years ago, it looked like it was just going to explode.
Mm-hmm.
There were lots of conferences on it. There were lots of talks to give and people to listen to and basically um, the general feeling was that it's going to replace the alcohol industry because you can make beverages. They're
Right.
potent, they're quick, they behave like the beverages behave timing wise like alcohol does. You have a
Mm-hmm.
glass of wine, 10 minutes later you feel the entire glass of wine, right?
Mm-hmm.
And so we all thought that it was going to be a serious competitor to the alcohol industry. I don't feel like it happened nearly as much as we all thought it would. I don't know why. I don't think it was a technological problem. I think it might have been
Mm-hmm.
regulations problem. Um, um, some uh, perhaps people are really used to using their lungs for
Mm-hmm.
cannabis, and it's going to take a
Mm-hmm.
little longer to make it sort of obvious that the mindset could be more like an alcohol mindset. You're also not allowed to consume it publicly in most places. So
Right.
that makes it a little bit more difficult. But I think it's going to happen. It's just the dynamic of it is not exactly um, what we thought it would be.
Yeah, and I think with just edibles in general, being that in a food substance, a powder substance, or even a liquid, it's going to affect everyone's bodies differently, just like vaping does, right? With some people, they can smoke an exorbitant amount of flower or dabs and not get high, and the same can be a scene for someone that says, "Oh, I've ate 500 milligrams of edibles already, and I don't feel anything," versus me, who's very sensitive, and I can have like a 10 milligram piece, and I'm just knocked for hours.
Well, it's true for any bioactive. I mean, it's certainly true for alcohol. I have friends who can drink the entire bottle of something strong, and they're completely
Yeah.
fine. I have other friends that can, you know, have a couple of shots and then you have to carry them home. So
So the next question that I want to ask: did you start out initially with cannabis in mind for your business, or were you focused on pharmaceuticals?
right, no, cannabis was a much later thing, and it
Okay.
happened actually. Well, it happened despite some efforts on our part. So we were mainly focused in the drug delivery space. We were mainly focused on the pharmaceutical industry.
Okay.
We were developing our systems for them. Our formulations were mainly developed for them. But uh, the I would say something like 5, 6 years ago or so, the cannabis
Mm.
industry suddenly exploded with this
Right.
need to do the same thing that the pharma needs to do, is to deliver bioactive substances into the bloodstream. The difference is that it's much easier in the cannabis space. The pharma
Hmm.
deals with all kinds of bioactives. Chemically, they're very different.
Right.
Uh, the cannabis space is cannabinoids, and cannabinoids, from our perspective, from the formulation perspective, are quite similar to each other. On the flip side, the farmer typically knows how to formulate. So we
Hmm.
helped with formulations, but mainly we worked with hardware. So we provided hardware solutions, systems, ultrasonic processors, mainly industrial scale ultrasonic processors to them. With the cannabis industry, it turned out that people don't really know how to formulate. In the beginning, we tried to assist and explain and all that, and then eventually we decided to just do the R&D ourselves and put it in a jar. So we
Hmm.
started offering what we call nanostabilizers,
Okay.
which are all-in-one formulations of everything that you need. So the entire formulation is there, and it's premixed and stabilized in such a way that to a user it looks just like one thing. It's like a gel, let's
Hmm.
say. One of them, it looks like butter. Maybe it melts
Oh,
easily at something like 50 Celsius. It becomes a liquid. Then you can dissolve your cannabinoids in that, add water, and process ultrasonically, and get the nanomulsion, and you don't need to worry about how to properly formulate anything. You follow instructions. They're very simple. For the
okay.
powders, it's also an all-in-one situation. To a user, it looks like a simple powder. You dissolve that in water, put your cannabinoids into that, a cannabis extract of some kind, process ultrasonically, get a liquid nanoemulsion, and you can dry that and grind it into a powder or spray dry
Wow.
it or whatever. So the cannabis industry came to us. We even tried to run a little bit because we felt like the pharma wouldn't like us working with the cannabis,
Yeah.
but then there was just so much interest and, well, frankly, money. There was a lot of money in it, and still is. So we went for it, and I'm very happy we did. Well, we were kind of early on. It was unclear how it was going to go, but now, in hindsight, it was a great decision.
Yeah, I mean, you made the business pivot to a new industry that you could take existing technology and make a better formulation for people that wanted to have a one-stop shop for this particular type of technology.
Yeah.
Uh, can you explain to the audience your recent findings of the nanoemulsion research conducted on this delta 8 molecule? I was reading that paper just a little bit.
Yeah, this was, as far as we know, the first study of delta 8 nanoemulsions and how they compare with traditional formulations, um, traditional oral formulations, digestive, MCT oil solutions, let's say, or edibles. Um,
Mm-hmm.
I have this poster behind me. Well, I'm not going to point to it; it's too far. But uh, long story short, um, with nanoemulsions, you get a much quicker absorption for the reasons that I went over.
Mm-hmm.
Um, Within the first hour of administration, which is typically the most interesting hour. I mean, you take something
Mm-hmm.
you want it to work, not
Yeah.
not 6 hours later, but hopefully within the first hour you want the effect. Nanoemulsions outperform uh, traditional edibles represented by MCT oil solutions by a factor of
Mm-hmm.
19, so almost 20 times more absorption. Within the first
Well.
4 hours, it's a factor of something like four, a little more than four. Now,
Mm-hmm.
another interesting finding is that if you consider the entire um, time period, so
Mm-hmm.
take it out to, let's say, well, practically it wouldn't be, but theoretically speaking, let's say, take it out to infinity and
Mm-hmm.
just see what the concentrations in the bloodstream are at each point in time for infinity. Add that all up. That's how much cannabis you brought into the bloodstream,
Okay.
right? So there is this concept of bioavailability being different for different administration methods. It seems that it's not true. And we kind of already knew that it wasn't true because when you study what is excreted, so let's say you do it on rats and you analyze their urine and feces, there's no
Mm-hmm.
cannabis in there. So where did it go? Well, it all went into the bloodstream, except
Mm-hmm.
it didn't go into the bloodstream altogether quickly. It goes in over a very long period of time, little by little, but eventually it all makes it in. So what you want to see is when you analyze it like this, you want to see the
Mm-hmm.
ultimate cumulative bioavailability over the entire period of time to be the same regardless of your administration method. That's exactly what we found. For two nanoemulsions and the MCT oil solution, over the entire period of time, the absorption amounts are the same, which kind of confirms the rest of it. What happens is the entire absorption pattern is shifted to the front. So everything happens quickly and then it's done versus
Mm-hmm.
oils that peak after 6 hours. The biggest amount is in your bloodstream is after 6 hours. And so it's very slow. And then there's this very long tail, which already you may not even feel
Right.
below the level where you can perceive it, but it's still going in. So this is what we found: much quicker absorption, much greater absorption within windows of administration,
Mm.
post administration windows of interest, and
Yes.
equivalent absorption over the entire period of time.
Yeah, that's fascinating. I think even just like you're saying, just being the first study and being able to notice that it's 9 times the amount of availability right off the
19,
after
right?
19.
19.
Yeah, 19 times is insane. That is incredible, and you're definitely going to be pushing that forward for other people to also test and repeat this same experiment in the future. Um, Real quickly, can you explain the importance of bioavailability to the audience when using products through consumption, be that nutraceuticals, pharmaceuticals, cannabis?
Sure. So bioavailability is a very simple thing. It's just what is the percentage of the substance you consumed that
Mm-hmm.
will arrive in your bloodstream. Um, Not everything that you consume goes into your bloodstreams. A lot of things just go, if it doesn't go in, it goes out. Let's put it that way,
Right.
right? For lots of bioactives, most of them are not going in. Uh,
Mm-hmm.
and that is one of the main issues. of the pharmaceutical industry. In fact, 90% of biologically interesting molecules under investigation of the
Mm.
pharmaceutical industry have this problem. 90%. And
Wow.
uh, about 40% of FDA approved drugs have that problem, meaning the rest of them are just not worth it's so difficult to bring them in that they're just dropped. They're dropped because, well, what are you going to do with them? You can't bring them in.
Right.
So with this technology, we bring them back into the R&D effort. So
Mm.
you can treat diseases that you previously would give up on, right?
Right.
So the bioavailability is exactly that. Now, I think a more let's say a more relevant term would be
Mm.
bioavailability within a relevant therapeutic window.
Mm.
For example, if you have a headache and you take an Advil
Mm.
and it works 4 hours later, then it's not a very good Advil pill that you took. But if it
Right.
works 15 minutes later, then you're good, right? So you want this bioavailability, which is the delivery into the bloodstream, to happen within a therapeutic window of interest as soon as possible for most things. Not all things. There are
Mm.
some things that need to be chronic. So bioavailability within the first hour is typically very important. Bioavailability within the first 4 hours is, I would say, after that. And that is just what is the percentage of what you consumed that arrived into your blood in your bloodstream within the first hour or within the first 4 hours.
Mm. So yeah, that's fascinating. You saying 90% has that problem
Of
in
90%
pharmaceutical?
of molecules that come out of drug discovery as
Yeah.
potentially therapeutically important
Mm.
are not are poorly water soluble.
Wow. Man, that's and then as far as like the nutraceutical world goes for, just taking vitamins and supplements on the daily, I, how much of that do you think is getting excreted? Like, are we actually absorbing all of this? Like, we're taking all these supplements daily, and I know nutrition plays a big role in what we need to get from nutrition altogether. But with this idea of having better health using supplementation, are we actually absorbing all of that?
Yeah, great question. Mostly no. Mostly you just throw them in the toilet, literally. This is a very complicated path. Um, some of them are water soluble. Let's say vitamin C. Vitamin C is water
Mm,
soluble. It goes right in. Um, Other things like vitamin D is taken as part of oil. Most of it is
mm,
not gonna go anywhere. Some will. Now, some other things are very low in bioavailability. For example, curcumin.
mm,
Curcumin, you can take grams of it and have very little in your bloodstream. It's just to get that delivered is very hard. Berberine, an awesome bioactive, very good for it's basically a natural alternative to metformin for diabetes. Very
mm,
low bioavailability because it's not water soluble. There are some other compounds that are strange in that sense. For example, alkaloids. A lot of bioactives are alkaloids. Alkaloids are not water soluble under neutral pH or basic pH,
mm,
and they
mm.
become more water soluble under acidic conditions. So
Okay.
let's say bioactives like mitragynine from kratom or mitragynine, I think, depending on how people pronounce it.
Mm,
It's water soluble under low pH conditions, a lot more water soluble, but it's not
okay.
stable. So you can't really make beverages in acidic environments because you're going to lose it. But if you just consume this leaf or leaf powder,
Mm, mm,
it will become water soluble kind of extract. Psilocybin from mushrooms is like that too. It's sufficiently water soluble under low pH conditions in the stomach. So
Mm.
its bioavailability is higher because of that. Um, so yeah, these are very complex things. So for some nutraceuticals, you are getting the benefit, or
Right.
many you're not. And nutraceutical field is not very regulated, so there's
Mm-hmm.
no real scrutiny and there's no real obligation on the part of the producer to give you any data, and so they can just say whatever and you can believe it or not.
Yeah, I think it's definitely hard to distinguish which actually benefits you and an overall like long term, and then you have to also think about it as maybe it's a little bit of placebo effect of
Yeah,
saying I am taking this on a daily my daily regimen and it's helping long term when in reality it could be just ending up in the toilet just like
exactly.
you're saying. So I think with the supplement industry moving forward, like what steps would be needed to make sure that we are getting these bioactive ingredients delivered to our bloodstream? What should companies take heed of?
Well, ideally, there would be studies. When you make a claim, it would be nice to show data that validates the claim. That's what
Absolutely.
we believe in. We bring this from the basically the scientific background and from working with pharma companies. Pharma companies tend to work that way.
Mm.
Um, but I mean, maybe in some cases, placebo is not a terrible thing. I mean, if it works for you, if it truly works, then why does it even matter why it works?
Yeah.
Unfortunately, what works is for one person won't work for another because of this placebo situation. And
Mm.
normally, drugs that are validated properly will work for most people. It's not
Mm.
that it's not that emotion related. It's more of a what I'm more comfortable with. I mean, just science and facts,
Yeah. More data driven
data
and
driven. Yeah.
results.
So
Yeah.
I would love to see more of that in the nutraceutical world. I think a lot of a lot of people distrust natural supplements
Mm.
because of this, and rightfully so, I believe. But maybe, um, well, it's unfortunate because I think there is a lot there. Natural substances are very powerful potentially. It's just that there's just not enough research. There's just not enough
Mm.
data. And maybe that's because that doesn't have to be for people to be able to sell them. You couldn't do this
Mm.
with pharmaceutical ingredients just because the FDA won't
Right.
let you. But with
Right.
nutraceuticals, they do. So, I mean, I'm not against regulating things to death either, but it would be nice to require people to have some justification, some way of backing up their claims.
Yeah, for sure. And I think that's getting implemented into cannabis now,
Right.
where you're starting to see companies are actually putting that time and research into making sure that their products are claiming what they're selling, right? And I think that's what's going to continue to push this industry towards a standardization of, being all on the same page. So I think the one thing that I wanted to ask would be if in your recommendation, like for a consumer to buy a product, you're saying you should focus mainly on something that is packaged in a way that is fat soluble or water soluble.
So what you would want in most cases is for the bioactive to be water compatible.
Okay.
I'm not using the word soluble because technically soluble means a true solution. True solution is
Mm.
not a nanoparticle suspension. It's when things are separated all the way down to individual molecules, surrounded by
Mm.
solvent molecules. But it doesn't need to be a true solution to be highly bioavailable. It could be a a nano suspension, uh, a suspension of nanoparticles, such as a nanoemulsion. Uh,
Mm-hmm.
so I like to use the word bio water compatible for that, because that is something that can coexist with water and get absorbed by getting to the right places in your digestive system, uh,
Mm-hmm.
by diffusing through water. So a water compatible state would be preferable for
Mm-hmm.
increasing the bioavailability. It's not always true. For some things, you may want slow absorption for chronic conditions, let's say.
Mm-hmm.
But for quick effect, yes, water soluble is definitely what you want.
For sure. So, what could clients expect for the future of industrial sonomechanics for projects that you're working on?
In this space, in the drug delivery space, let's say,
Mm-hmm.
we have recently begun to go after interesting bioactives.
Okay.
We believe that what we have in the cannabis space is good for most people. We've been enabling our clients to create nanoemulsions, and
Mm-hmm.
for now, liquid and powdered nanoemulsions is what people want, and so our R&D efforts have at this point shifted to other bioactives that are difficult.
Okay.
We're working with a company on curcumin formulation.
Mm-hmm.
We have made a water soluble berberine formulation,
Okay.
which is seems very effective. So we're going to study that next. We have formulated lots of different alkaloids. For example, mitragynine or mitragynine from kratom. We've made that
Mm-hmm.
water soluble under all conditions, basic or acidic, and stable permanently. So it's a freely water soluble powder. We can make effervescent tablets out of it, so you can make beverages. That has a lot of potential. Lots of people expressed interest in that. Piperin is another alkaloid that is difficult to dissolve in water, and we've made it freely water soluble, and so on. So we're expanding our portfolio of formulations.
Mm-hmm.
Interestingly, because all these things are different, they require different formulation efforts. So it's a kind of a start from zero every time. A
Mm-hmm.
big one is mushroom extracts. Not only psilocybin, although psilocybin is certainly interesting, but all kinds of mushroom alkaloid extracts are very interesting. And we're working on both extraction of that
Mm-hmm.
and formulating the extracts in a stable and freely water soluble state. In parallel with that, we've launched a line of ultrasonic extractors.
Okay.
Ultrasound is a very well known cell disruption technique. Most biological labs have a small sonicator for cell disruption. That's how you get things
Mm-hmm.
out of cells. But as I explained at the beginning, there's this reputation of this technique not being scalable. So we've scaled it up, and
Mm-hmm.
we make from lab to large industrial scale ultrasonic extractors, all in one kind of setups for people to get alkaloids from mushrooms, so or from kratom, extract other things. So we are expanding into the nutraceutical market on all fronts, I would say.
So, with your ultrasonic extraction equipment, so basically you're taking raw material and putting that, you're breaking it up with your ultrasonic equipment, and then once you have the desired molecules released from the cells, is there there's no solvent involved in that next stage, or how are you pulling out those desired compounds and leaving behind the undesirable?
Yeah. So yes, you do need a solvent. It's a solvent
Okay.
extraction technique. Now, ultrasound, um, well, cavitation-based ultrasound of the type that we work with is a liquid processing technique. So we can work
Okay.
on liquids, slurries, mixtures of powders and liquids, things that flow. So to extract, you need a solvent, and let's say mushrooms. You need a powder of your biomass, so powdered mushrooms,
Mhm.
dried powdered mushrooms. Your solvent, you mix it together in a ratio that can still flow. You sonicate that.
Mhm.
That breaks up the hyphae cells, the
Mhm.
mushroom, well, hyphae they're called. Uh,
Mhm.
they're tough. They're difficult to break. Ultrasound is able to crack them. The solvent washes the contents out, and then you have to get rid of the spent biomass, normally by
Mhm.
centrifugation slash filtration. Now you got your solvent and your biomass, then you reclaim the solvent. Oh, sorry, now then you get the solvent and the extracted material of interest.
Compounds.
Then you get rid of the solvent, reclaim it, and you may need to refine the extracted material or not, depending on what it is.
Mhm.
Now, the advantage of using ultrasound is not only are you able to crack the cells and get the materials out a lot quicker and more efficiently and with higher
Mhm.
yields, but in most cases, you can go to much milder solvents because instead of relying on the aggressiveness of the chemical,
Mhm.
of the solvent itself,
Mhm.
you're replacing that with the mechanical ultrasonic cavitation energy. So you
Mm.
can kind of pull back a little bit on the aggressiveness of the solvent. So in many cases, you can use ethanol instead of methanol, let's say, or even
Okay.
water ethanol mixture instead of that, or maybe even pure water in many cases, or maybe
Mhm.
water with a little, acetic acid, let's say, for some things.
Okay.
So you can go to milder and greener food grade solvents where otherwise you couldn't. You can get very high yields and rapid processing times. But then once the ultrasound device is turned off, that extra energy obviously doesn't stay behind. So now
Mhm.
you're left with a green solvent and the material of interest that's dissolved in it. Then you reclaim the solvent, and the purification and the refinement, that is not part of what we do. This is the sort of downstream processing that's pretty well worked out for most substances. So we that's how far we take it in our process.
Okay. And as far as scaling goes, how big or how what's the range from smallest to largest?
So our systems scale from what people typically are used to as an ultrasonic
Mhm.
device by approximately a factor of 60 to 100. So our larger system can process in less than a minute what otherwise would take you over an hour.
Wow.
Now, beyond that, you put systems in parallel. And our systems are modular. So to put them in parallel doesn't mean that you would have the entire system replicated several times. You have the business end of it, which is the react. Well, I can actually show you. This is what the business end of a typical ultrasonic system looks like. You put it in a small volume like
Mhm.
this, maybe 40, 50 mils maximum. This is one of
Okay.
our barbel horns. So it's scaled up because the
Nice.
area, this area is much bigger,
Mhm.
and
Yep.
the scale up factor goes like a little bit more than the square of the area because
Okay.
cavitation is actually a volume, it's a cone, so it gets bigger and deeper. So it's something like
Okay.
a little bit more than a square of the ratio of the areas, the scale up factor.
Mhm.
Plus, this thing has more than one cavitation zone. One is here and one is in between here. So the scale up factor from here to
Mhm.
here is approximately 60. I believe for this one it's 65.
Okay.
And then this thing goes into a reactor chamber that looks like this. This is an industrial
Okay.
reactor chamber that I'm able to lift somehow. This is a hole that goes in it. It has a cooling jacket on it, and the liquid just flows. It flows in here, flows out there, and recirculates until it's done. Now, if you go
That's all.
beyond that and need to scale up to much larger volumes, which is it happens pretty frequently, especially in the pharmaceutical industry for large
Mhm.
nanomulsification processes. Then we have things like uh, colla- um, A typical setup was a cluster of nine of these. They're in
Okay.
the cube, kind of all the corners and the center of the cube. Nine of these, and they're all
Hmm.
in. There are three series lines of three parallel. There are three parallel lines of three series systems,
Okay.
and then the
Yes.
drivers are in a common rack elsewhere. So there's no limit
That's
to how
awesome.
much you can scale up. This is modular. You just keep, putting them in parallel until you hit your target. And
Man,
I have
it's
to mention that we don't only work with pharma or food and beverage or nutraceutical related stuff. We work on fuels, desulfurization of crude oil, for example, degassing aviation fuels. Completely different applications where volumes are much greater. So it's very
mm,
typical for us to provide clusters of nine into those industries. Desulfurization of crude oil was actually one of our earlier applications in parallel with pharma
okay.
that went very well.
That's awesome. So this technology can branch out into multiple industries. So you're constantly working on different projects and doing R&D. That's fascinating. I think that that's the most exciting thing about science is that you can apply it to almost everything that we touch on a given basis throughout um, your existence, right? Uh, the last question that I wanted to ask you is, where do you see the cannabis industry in 5 years, maybe internationally?
Well, I believe that the original understanding of where it was going to go is still valid. It's just slowed down, possibly with COVID or just because we overestimated the excitement that people would have in switching from smokable and vapable products into beverages. But I still believe that everything is going towards beverages. In five
Mm-hmm.
years, I believe there's going to be a much greater awareness of the benefits of the beverages based on cannabis, possibly competing with the alcohol industry, possibly cooperating somehow with the alcohol industry.
Mm-hmm.
And internationally, I believe so. Yes, because we're feeling this interest from all over the world. We sell
Mm-hmm.
everywhere, and I would say the entire world is moving at about the same speed towards that. Europe is a little slower. Asia is a little faster. Thailand, places like that.
Mm-hmm.
Um, Not all of Asia is faster, but there's steady movement everywhere. Canada was faster. Now they slowed down. It's kind of like this, but it's all going. And I believe in 5 years, it's going to be a lot more. And there's probably going to be a moment when it just kind of the dam breaks.
Right.
Hopefully.
uh, it's just the USA is at the forefront of it right
Yeah.
now, so everyone's taking notes on what's happening here. But now this has been a great conversation, Alexei. I'm so happy that I got to sit down and talk with you today because I learned so much. I've never looked into ultrasonic extraction or just sonification in general. My understanding coming from a medical background was just like, oh, it's ultrasound, so you're just
Yeah.
doing imaging
Different
throughout the
kind. Yeah.
body, but there's just so many other applications for it. So no, this was it was good to take what you're doing and mind map it into what I've already done in cannabis and the nutraceutical world.
Yeah. Thank you for the opportunity. I love talking about this stuff. Any chance?
Yeah, man. No, I could definitely tell just by just right off the bat, your level of interest and just overall use of chemistry times physics and being able to apply that knowledge specifically into a company that could branch out into helping out in several industries right off the bat.
Awesome.
Cool, man.
Thank you very much.
Well, I hope you have a good day in Miami. Enjoy the sun, and
Thank you.
we'll talk again in the future.
Very good. Thank you very much. It was a
Thank you
pleasure.
so much.
Take care.